In this video, you're going to learn about properties of logarithms. So, like in your example in your beginning of your packet, they randomly give you some logs to take. The great part about these ones is you can use any calculator, including the one on your phone. As in the last lesson, we learned that when there is no number down here below the log, the base is not there, it actually is a 10. So we're in base 10, but that's the one that's the most common. So any calculator actually has this button. Of course, you could use Desmos as well. So we're just going to take log of 2, and we see it's 0.301. We take log of 4, and we see it's 0.602. We take log of 8, and we see it's 0.903. At first, you think you're just taking some of these random logarithms, and you get the numbers, and you're done. But then they ask you to look at some interesting patterns with the numbers. So, for example, you had a 2, and you had a 4. And I wonder how we would relate that to the 8. Well, if you took 2 times 4, of course, you'd get 8. But I wonder if there's any relationship between our actual decimal answers, so our 0.301, 0.602, 0.903. In this case, we could look at adding them. What is 0.301 plus 0.602? You guessed it, 0.903. It's not a coincidence. This is our first property of logarithms. It states that log of any a number times b number, so like 2 times 4, would be the same as taking log of a plus log of b. That's your first property of logarithms, the multiplication property. Well, guess what? It works for division. I have log of 8 divided by 2. So it says to divide. Now some of you might be saying, well, then that's just log of 4. Let me type that on my calculator and I'll get you a number. Log of 4, we actually already know from the last slide, is 0.602. I'm done. That's true and it works, but check out how it actually follows the subtraction rule as well. We did addition when we were supposed to be multiplying two numbers. If doing division, you have log of 8, the top number, the numerator, minus log of your denominator, the 2. 0.903 minus 0.301 does give us 0.602. This brings us to our division property for logs. It says log of any b divided by a, any two numbers, would be the same as taking log of b minus log of a. And that's our division property for logarithms. Now here's a neat one. Log of 2 to the third. Let's recall that 2 to the third power means 2 times 2 times 2, which is 8. So some of you might be saying, wait a minute, I'm just going to take log of 8 and be done. We know that from our first slide to be 0.903. But I want to show you a property about logs. Since we can rewrite it as log of 2 to the third, we could have rewritten that as log of 2 times 2 times 2. Because that's how we get 2 to the third. Well, from our first property, multiplication could be written as addition. So we could have written it as log of 2 plus log of 2 plus log of 2. We know we have 0.301 if we wanted to write that number in below all of those, but how many log 2's do we really have? We've got 3 of them, right? So that's 3 times log of 2. Now, like I mentioned, if you want to write 0.301 and add those all together, you can, but aren't you technically taking 0.301 times 3? That would, of course, give us 0.903. It does give us that same answer, and either way is fine to do that, however you see it. But this gives us our power property of logs. So, if I had log of a to the b power, this little power can trickle down out to the front here, okay? So I'm going to undo that little part so we don't have a little straggle there, but I was showing you where it will go. It'll be b times log of a. This is our power property of logarithms. All right, so let's take a few examples here where we're going to rewrite this condensed logarithm as separate logarithms. We're going to expand it, if you will. Notice how I have some key highlighting here in pink. I also want to point out that this is a base 3. Even though it doesn't have a base 10 like the other ones did, we use that to be able to use our calculator really quickly. But these properties work for any base. All right, so when I see a multiplication, I'm going to be probably thinking addition of them separately. And when I see division, I'm going to be thinking of subtracting them. So we would start with writing it log base 3 of m to the third. And then we have our multiplication. So we'd write it as log base 3 again of p to the fifth. And subtraction for our division of log base 3 r squared. Now this is a great first step, and sometimes I even forget to keep going on, but notice how we have this exponent out here. One way we could break it down even more is use our power property. So I could rewrite it as 3 log base 3 of m plus 5 log base 3 of p minus 2 log base 3 of r. We can really break that down into using the power properties and the multiplication and division rules. All right, let's try another example. Here's another one we could expand. So I see a division sign, it's going to mean subtract. I see a multiplication here, and I also see an exponent, so I have to use my power rule. We're in log base 4. That basically just means I have to write that log base 4 a million times. So log base 4 of 7, subtract log base 4 of 2 times log base 4 of v to the fifth. Now we're going to pause right here for a second. You see how we're actually dividing by all of this bottom quantity? So all of this guy is being the division, the denominator. That's important because we have to remember then to put parentheses around our subtraction sign. We're dividing by all of that. So I do want to handle this power. I'm going to rewrite that with the power out front, following the power property of logs. But it's important that since we were subtracting here, it applies to, oh, and I just realized, my apologies, this multiplication here between 2 and v5 needs to be a plus sign. That would be the property we were talking about. All right, there we go. Same thing here now. So the reason I wanted to bring that up is this subtraction sign should filtrate through all of those parentheses. So let's clear up my mess here. Sorry about that. I have a log base 4 of 7 minus log base 4 of 2 minus. The subtraction comes from the fact that we were subtracting all because of the denominator here. I carry that through, and I'm going to bring this power down out front for that power rule. So I've got a 5 log base 4 of v. That should be my expanded form of the original logarithm we were given. Now sometimes you're going to be asked to condense your logarithm statements. So here I have 3 log base 2 to 4, 5 plus log 5 log base 2 of p minus log base 2 of r. Whenever I see the addition, I know there was a multiplication operation going on in the condensed version, and the same here with subtraction, it would have been a division. So I'll be staying in log base 2. This little guy out front is going to go condense and become a power again. Same with this 5. All right, so we're going to have log base 2, and our 4 is going to have an exponent of 3. It's an addition sign now, so we're going to change it into multiplication. The nice part about condensing is you actually only have to write this log base 2 one time now. All right, so we have plus 5. The 5 is going to go back on top here, so I'm going to have p to the fifth. And then because of my subtraction sign, I'm going to divide by r. One thing we can do to condense it just a tad bit more is we can actually take 4 to the third. So we've got log base 2 of 64 p to the fifth over r. And that should be our final condensed answer. All right, here's where it gets a little bit crazy. We've learned the 3 properties for multiplication, division, and power rule. But there's a change of base formula. So kind of follow the steps here. Remember, when we have a base, we've been working with just log a lot, which is the 10. So there's normally a 10 down here. Since that every calculator has that, it's nice just to have that 10. So there could be a different number down there though. And if you ever don't want that number down there, we can rewrite any base as a base of 10. And here's how we're going to do that. The first step will be you're going to multiply, this is our example, log base 2 of 3. We'd rather not have this be any base 2. We want to only have base 10. So your first step is to multiply by log 2. You might say, why the 2? Why are we going to have 2? Well, 2 comes from the fact that we're kind of trying to get rid of that base. So we're going to multiply by log 2 over log 2. Why a fraction of it? Well, multiplying something by 1, because remember anything over itself, so like 7 divided by 7, 9 divided by 9, it always makes 1, so you're not really changing it. So multiplying by log 2 over log 2 means I didn't change anything, I'm just multiplying by 1. All right, here's where it gets a little crazy on that worksheet when they walk you through it. Whenever you have a number out front, so they could extend this line, whenever you have a number out front, he can go be the power of this number with the power rule of logs. So we could rewrite this as log 2 to the power of log 2, log base 2 of 3, all over log 2. Now, this is where it gets a little bit like magic, and it's fine if you want to treat it like magic. This number right here, 2 to the power of log 2. 2 is in an exponential. It's like 2 to the power of x. This is an exponential equation. But logs are the inverses. Logs and exponentials are inverses of each other, which we discussed in the last week. So these essentially just get canceled out. The 2 log base 2 to the power of log base 2, they're inverses of each other. Kind of like if someone told you to multiply by 3 and then you divided by 3, they would just cancel each other out because multiplication and division are inverse operations. So are taking something to a power and taking the log of it. So these cancel, and all you're left with is log, and your 3's up there, so you log 3 over log 2. This is it. There are no bases anymore. You have no base down here in either one of them. You've changed the base of your original log base 2 of 3, and they're now into log base 10. Let's try this one. So I've got, I don't like base 5. I want to be able to use my calculator on my phone. So to get rid of him, I'm going to multiply by log 5 over log 5. It's kind of like multiplying by 1. Just looks scarier. Well, remember, if you had this out front, he can become the power. So we'd put him out front, and we'd have log, or up top there, log 5 to the power of log base 5 of 8. And we still have it over log 5. These parts right here, this part right there cancels because an exponential and a log are inverses of each other. So they cancel. We're left with log 8 over log 5. In this time of quarantine teaching, let's break it down to exactly what that means. They are saying, notice how when you started, the 5 is the base you don't like. Look where he ends up, in the bottom. The 8's the number. That was the input, or the x value, and there he is. Here is our change of base formula. If you ever have log base b of m, you can rewrite it as log of m over log of b. I've showed you the steps and how they cancel, but this is your lifeline for changes of base.